Okay, everybody, Mr. Taylor back. I just want to go ahead and complete our scenario on dimension analysis and just take a look at problems 4 through 14. So we're going to go through probably about 10 problems. These are the key to the problems, and so if you want to check your work that you did in class, come back to this video. So problem 4 says a problem solving method known as dimension analysis may be used to convert inches to centimeters and centimeters to inches. Dimension analysis allows you to determine which way to write the ratio so that units will be canceled and leave only the desired unit in the answer. So let's look at A. It says fill in the missing information to convert inches to centimeters. So 7 inches, they say, is 17.7 centimeters. Okay, so we can cancel as we go and leave only centimeters. So if you notice, 7 inches, that could have been wrote 7/1. So let's not, please, let's understand that, because I definitely want you to know that could be 7/1. But the author did not choose to do that. So remember, we have 7. And 7 is going to be multiplied by 2.54, but notice that we cancel the inches by, remember what I said, cross division, so that can cancel and you left with 7 times 2.54, and the only unit left is centimeters. Okay, so this is where our centimeters come from. Okay, B, fill in the missing information to convert 24 centimeters to 24 centimeters to inches. So again, just like we said earlier, whatever you're converting to would be on the top. So we have 24 centimeters out here. That's just the same as, like I said earlier, putting 24 over 1. So now we know that 1 inch over 2.54 centimeters, we're going to, centimeters are going to cancel out. That's leaving us with 24 times 1 inch, and that'll be 24 over 2.54 inches. Okay, now just as long as you understand that you just, and again, as I've told you a million times, please stop, listen, take notes. You know, only got 15-20 minutes to put these up. Just stop, take notes, and then maybe when the next problem comes up, you might want to look at it individually and say, hey, let me do this before he even gets started. Okay, problem 2. Or should I say page 2. So now this one, again, we're just giving you insight on what dimension analysis does. But again, we're going to convert to other units of measure, and we're going to use this particular ratio that they're giving us here. And then please pull out your STAR 8th grade math reference material chart and see how can you perform. And we're going to look at this, use this information for problems 5 through 8. So let's see, how many liters of lemonade are equivalent to 5.5 gallons? Liters, and we're going to convert to gallons. So notice we have 5.5 here. We're converting to gallons, so we have 5.5 here. We're converting, and liters is on the top. So notice 3.79 liters, 1 gallon. Gallons cancel. Okay, so we're left with 5.5 times 3.79, as we are showing here. And from here, we know that the only unit we have left is liters. So our answer, once we multiply the constants, is 20.845 liters. Pretty straightforward. Okay, 6. So how many pounds are equivalent to 15? How many pounds are equivalent to 15 kilograms? So here again, we're going to cancel the kilogram. So if we go and look at our chart back at the top, we'll see that it's 2.2 pounds to 1 kilogram. And here's the other ratio, 1 kilogram to 2.2 pounds. But since we are converting to from pounds to kilograms, then we're going to take 15 kilograms and we're going to use this particular formula, the 2.2 over 1. So 15 and 1, the kilograms cancel out. We're left with 15 times 2.2, and pounds is the units that left, and that's going to give us 33. Okay, so let's see, can we do 7 and 8? Remember, I hope that you go ahead and copy this part down. So stop the video, copy this part down, because we're going to use this for problems 7 and 8 as well. Okay, let's go to the next page. Okay, so again, how many feet? So equivalent to 39 centimeters. Go back to your original information. Go back to your original information, and if you do, you'll see that you're going to use the 1 inch to 2.54 centimeters. That's the one we're going to use. And we're going to cancel the units of centimeters, so we can just be left with feet. So 39 centimeters on the outside, and we're multiplying that times the ratio 1 over 1 inch over 2.54. Again, as you see, centimeters cancel. Now, think about this. 1 inch, is that helping us with feet? Well, we can convert. We know we need to convert now as 1 feet to 12 inches. So now you see how we put this other ratio in, but again, we have 12 inches, and we're going to use 1 to 12. Look, inches cancel. So we left with 2.5, 1 times 1, but that's feet, 2.54 times 12, and then the top part is times 39. So as we cancel out, let me make this a little clearer for you. We're left with 39 times 1, inches are gone, right? And times here 1 feet. And here on the bottom, we're left with 2.54 centimeters are gone times 12, inches are gone, and the only thing that we have left is 39, right, over 39 feet, and the bottom part gives us 2.54 times 12. Okay. Now, number 8. That's the very last one we're going to do in this particular series. But we're using the information that we were given. How many fluid ounces of soda are equivalent to 1.5 liter? Again, what are we trying to do? We will cancel the liters so we can have only fluid ounces. So 1.5 liters on the outside. We go back and we see that in order to get liters where these liters going to cancel, liters are on the top, liters need to be on the bottom, and the 1 gallon to 3.79. And we can cancel out our liters. They're gone. We're left with 1.5 times 1 gallon. But that's not going to help us with fluid ounces. So we need to go to our math chart, and we can see that is 128 fluid ounces to 1 gallon. So now the gallons take a plunge. They're gone. The only thing that we have left now is 1.5 times 1, which is here and here. 1.5 times 1 times 1.28, but the fluid ounces remain. Okay, so now on the bottom we're having 1 times 3.79 times 1. There are no units. The only units left is fluid ounces, and we multiply and simplify, and we get 50.7 fluid ounces. Please stop, take notes. Please stop and take notes. I mean, it just won't do us any good just to copy it and bring it to class and say, here you go, sir. Can I have extra credit? No, let's take the time and stop and make sure we understand. Because we know that somebody is talking, your friends are saying, hey, what's going on? I did this on Instagram. And you really, really, really need this type of information so you'll know as we go forward. Okay. Problem 9 and 10. So what we want to do is we just want to really, really get down now to more or less real life application and see can we use this dimension analysis to solve. So this particular problem asks us to place a fence around an air conditioning unit, and I think we actually took a look at some similar to this with a picture, but dimension analysis can show us how we can actually do it without actually drawing the picture and then doing the big conversion. So let's I think it's interesting because, again, like I said, we looked at this previously when we were doing the sample measurements. So he has a unit measure of 1 meter on each side. If we drew this picture, we'd know what that looked like. If he's talking about one meter on each side, if we drew the picture, see, it'll be just 1 meter, if you remember. So you got 1 meter here, so it's going to be, if it's a square, it's going to be 1 meter all the way around. So if the dimensions are converted to inches, how much fence is needed? So here, let's see. So we want to convert meters to inches. So we start with 1 meter according to your 1 meter is 100 centimeters. So we can go with 100 to 1, and then this way we can do what? Cancel out the meters, and we're left with 1 times 100 centimeters. But now we need to know, well, how many centimeters is in an inch? Well, 2.54. So let's cancel out this part. So the only thing now we're left with is 1 times 100 times 1 inch. So again, we're left with our inches. And then on the bottom, we have 1 times 2.54. And then we simplify. So what are we talking about? If we're going to do the perimeter, it'll be 4 times, because see, now we've gotten it to 39.4 inches. So now 4 times, it says all 4 is the same. So we have 4 times 39.4, which is going to give us 157.6 inches, and the area would be 39.4 inches square, which will give us 1,552.36 square inches. Okay, just another way of doing it. Now, the next problem, well, again, is the exact same thing that we looked at earlier. Only now we're not drawing the pictures. We're gonna look at it through dimension analysis. So this individual want to frame a tomato garden with barbed wire, and then we have our particular conversions. Remember, it was 1.5 to 1, and if they are converted to yards, how much barbed wire is needed. So again, just another way to look at it. If you remember the picture that we had, the picture was something like 1 and then 1.5 here. So if we're going from meters to yards, and we're just really doing the same thing. 1.5 meters, 100 centimeters to 1 meter. Then we're going to do what? Meters are going to cancel. And then here, centimeters are cancel. And then here, inches are cancel. And then we're just multiplying 1.5 times 100 times 1 times 1. And our denominator is 1 times 2.54 times 36. And we're left with yards. Okay? And then and that's just length. And then we do the same thing for the width. There we go, 1, it's gone. Centimeters, they're gone. Inches, they're gone. And we're just left with yards. And then once we get what we're looking for in yards, then we can add to get using our formulas to get the perimeter as well as the area. Okay, So again, 11 and 12 pretty much works the exact same way. The only thing you're doing is reading the problems and working the problems from dimension analysis. And again, guys, listen. This is you're gonna get the same answer if you draw this picture. The only thing is you're doing your conversion as you work. So go ahead and take a look at 11 and 12. Compare it to what you did. Stop it. Make sure you fully understand. And 13 and 14 as well. Um, Again, these are things that we had already looked at with the sample measurements. We worked the problems according to drawing the picture and converting first. But on these, we're using the analysis to make sure we can convert as we work. So problem 13, take a good look at that and make sure you understand. Again, it's the exact same stuff we did. And 14, make sure you again stop these videos, fully understand what we worked in class and how we worked in class, so you can make a determination when you're working your exam April 1st, whether you want to literally go through the conversion of the actual typical method, or do you want to use dimension analysis? We still need to know dimension analysis as we go forth. And like I told you, it is a good thing to use when you're doing science. So again, take a look at 13, 14, and compare this with your work to make sure that you fully understand what we covered in class. All right, Mr. Taylor, Rockin' Math. I'll talk to you soon.